Hello and welcome to today's GFG problem of the day. So let's see what the problem says. You are given an array A of n elements. Find the minimum index based distance between two distinct elements of the array x and y. Written -1 if either x or y does not exist in the array. So let's quickly see what the problem has to say by an example. So if given an element, right, what will be the input? The input will be array, and they will give us two elements x and y. X is 1 in this case and y is 2. So what they're trying to tell is you have to find these elements, okay, in the array, and you have to return the minimum distance between these two elements, right? Between these two elements. So let's so here so here one x is here, right? One is here and two is here. So the minimum distance would be one, right? One minus zero would be one minimum distance, right? This is 0 1 index, right? 0 1 2 3. So 2 minus 1 sorry, this 1 minus 0 will give you 1. Similarly, we have 1 and 2 here as well, right? 2 here as well, x and y, right? But the distance, if you see, right, 3 minus 0. So the distance is 3. So we have to return minimum distance. We have to return minimum distance. Okay. So so this problem is pretty easy, right? So what we can do, and what is the time complexity given? O of n time complexity is expected, and big O of 1 is the space expected. Okay. So let's quickly see what we can do. We can solve this problem by using two pointers, right? So which will initialize as L -1 and R equal to -1, right? Okay. So what we'll do whenever we find, right, we'll iterate through this array. We'll iterate through this array, and wherever we find x, right, we will mark it as L. For example, we'll iterate through this array, right, for I equal to 0 to n, right? I equal to 0, and if a of I equals x, right? If a of I equals x, then we'll simply what we'll do, L equal to I, right? Similarly, if we find a of y, if we find y, right? If a of I equal to y, right? We'll mark R as I, right? We have to capture the indices. And once, for example, we get those indices, right? We get those, we are able to capture. What we'll do is, if L is not equal to -1, right? That means we have found the x element, and R is not equal to -1, right? Okay. So what we'll simply do is we will take our answer, right? An answer, right? Int answer equal to max int, will take max int, right? We'll take max int. Int answer equal to max int will take, right? We want to find the minimum, right? So what we'll simply do, if we have found L and R, right, the indices, what we'll simply will do, answer equal to minimum of answer, and absolute value of R minus L, right? So yes, in this way we'll get the answer, right? In this way, okay, in this way we'll get the answer, right? So for example, there can be the case that we did not find either x or y or both of them. So in that case, what we have to do, this answer will always will not like we so this answer will always be max int only, right? Will always be max int only. It will never go into this loop, into this line. So what we'll simply do is return answer, if answer equal to max int. If it is still max int, then return -1, else return answer only. So this is the solution, and it is adhering to O of n, right? Time complexity O of n. We are iterating the array. We are iterating the array O of n, and we are taking no extra space. Okay, so it's O of 1. So this is the approach, right? This is the solution. Let's quickly implement the problem. Okay, as I said, int L equal to -1, right? Int R equal to -1 for int I equal to 0, I less than n plus I. If a of I equal to x, if we get x somewhere, then what we'll do, we'll capture the index. We'll capture I in L. Similarly, if we find y, then we are going to capture the right index, right? And we want answer variable, minimum answer equal to integer dot max value. For different languages, it can be something different for this integer max value. Okay. Then what we are simply going to do is, if L is not equal to -1 and R is not equal to -1, then minimum answer equal to math.min. math dot minimum answer, and math dot absolute. We have to take absolute, right? It may happen that R has appeared before and L has appeared later on. Okay. So we'll simply what we'll do, min answer equal to integer dot max value, right? Integer max value. If it is, then we have to simply return -1, else minimum answer we have to return. So let's see, we are able to get it right. So the idea here is to find the minimum distance, right, between the elements x and y. So yes, I think the problem is accepted. Thanks for watching. Kindly like the video and subscribe to my channel. It will motivate me to create the videos for you. Thank you so much.